In this video, you will learn what a distance time graph is and how to use it. So, let's assume Aya drives a car from his house at point A to the university at point B, 11 km away. He waits there for 1 hour before continuing on his way to football practice 9 km away from the university and arrives 1 hour later. He stays there for 2 hours before returning home. What we have just seen is the formation of a distance time graph documenting Aya's journey. The line A to B shows him traveling from his house to the university. Because this is a straight line, it indicates that he is traveling at constant speed. The flat line B to C indicates that his speed is 0 and is at rest. Because speed is found by dividing distance by time, so on this graph, it is represented by the steepness of the line, also known as the gradient. To calculate speed from a graph, we need to measure the gradient. We do this by selecting the 2 points we want to find the gradient of, then finding the change in distance and the change in time. Let's try to find the speed of point A to point B. We can see that the change in distance is 11 km and the change in time is 2 hours. Hence, speed is distance divided by time. We divide 11 km by 2 hours, which gives us a speed of 5.5 km per hour. Let's find the speed for points C and D. The change in distance is 9 km with a time of 1 hour. So we divide 9 by 1, which gives us a speed of 9 km per hour. This tells us that the steeper the gradient at the points on the graph, the faster the speed. The flatter the gradient, the slower the speed. While a completely flat line indicates no speed at all. When the line is in the negative direction, this shows that the direction of travel is opposite, such as back home. Let's work out the speed in the negative direction. The change in distance is 20 km in 2 hours. That means the time is 2 hours. So the speed back home is 10 km per hour. If a line is curved upwards on the graph, it is showing a change in speed and acceleration. If the line is curved downwards, it's also showing a change in speed but a deceleration. In other words, speed is not always constant. Sometimes an object will accelerate with the graph curving upwards or decelerate where the curve levels up then curve downwards. Some practice question for you. Pause the video and give it a go. What does the gradient of a distance time graph show? What does the different line forms indicate on a distance time graph. You have the upward steep, the downward steep, the flat line, uphill and downhill.